All right, you guys. Hopefully you had a chance to log in, play around, do some of the preliminary stuff for the first homework assignment, which I remind you is due Friday. So in particular, if you haven't filled out the information form, please do that. And then I would hope that most, if not all of you, have at least played around with some of 2, 3, and 4. And Hello World I have essentially done for you. Just make sure you include some kind of above and beyond in yours, and that can be as simple as just printing out something else other than Hello World. It's really just to get us comfortable with the technology. Also, I logged into Math, I don't know, yesterday or the day before, and I noticed there was quite a crowd there. There were probably, 12 or 13 people logged in there, and I thought, Math is a fairly busy computer in general. So what I've done is I had WCTS actually open up access to 6 more machines in the Math lab, and let me log into Math and show you which machines are newly available. Okay, so here I am on Math. If I type U, I see there are 3 people on there, 2 other than me. And that's something that you want to do. You want to check out how crowded the machines are, and you want to sort of put yourself on less crowded machines. And I showed you this command finger at Math, which will give you information not only about the computer that is math.whitman.edu, but in fact all the computers that are associated with it. Right now it's pretty quiet in the Math lab. There's no one logged in on any of the machines. What I've done is I've opened up 1, 2, 3, 4, 5, 6 from Phoebe down to Themis. So Phoebe through Themis you can treat exactly like Math. So you have 7 machines that you can log into remotely. And I should also add that if you're on campus, like for example right now your laptop is connected to, say, the wireless network or something, or if you live on campus in a dormitory, in fact all of these machines are accessible to you. It's just people that live off campus, only these last 6 machines, Zeus is not in there, but these last 6 machines are now available off campus as well. So again, I would encourage you, if you log in, to look around a little bit, see who's on the machine, and try to get yourself on a quieter machine. And in fact, I would encourage you to avoid Math altogether moving forward, because Math actually serves up the department web page and whatever, and if you do something crazy in your program and you crash the computer, then you're going to take down the department web page, and that's not a good thing. So it's really unlikely that you would be able to crash the computer. But if you're really industrious, you can get it. You can do such things. So just keep that in mind. How would that work in PuTTY? So perhaps you log into Math, you look around, you see that say RIA is fairly empty, so you would just log into RIA. And you're going to get this question about the key. Just say yes, and then it's the same login. And if you look around, you see all the same files that you had on Math, because these files are just automatically distributed to any computer that you happen to be logged into. Questions about that? Go ahead.
So if we start using the RIA, we save something on there, and then we want to come back and we see that RIA is...
And you log in here, it'll be there. It's just automatically, yes. Whatever you do on any of these computers is instantaneously recognized by the other computers. Okay.
So we just push U then?
U is short for users, And that tells you who's logged on to that particular machine. And then this other one, finger at math, gives you a list of all the computers in the math lab. And unfortunately, right now, there's nobody logged on. I don't know why math doesn't show. Oh, I know why. This only shows people logged in at the console, like actually sitting in front of the hardware. It doesn't show who's logged in. So what you might have to do is log in, look around with the U command, and then log out. What I may try to do is tweak this a little bit so that it not only shows who's logged on in the console, but everybody who's remotely logged in as well. I'll try to get on that sometime in the next couple of days. Other questions? Okay, what I wanted to do today is spend some more time talking about this new editor, Vim, that you have been saddled with, and then I will write a program that converts Fahrenheit to Celsius, and we will dissect and talk about the components of a functioning C++ program. All of the things that I'll show you today, at least in when we're programming C++, all of those things I will revisit later in greater detail. What I'm handing around right now is something called a Unix cheat sheet. And I'm not a big fan of paper. Usually I just distribute everything electronically. The reason I'm giving you this on paper, Rachel, is when you're working in this environment, right, you've got Unix commands that are recognized here, and then you go in and you're editing your file using Vim. When you're working in this environment, it's really helpful to have these two pieces of paper sitting right next to you to remind you what all the commands are. So just keep those two pieces of paper handy, and frankly, it's really just the first sections of both of these that you're going to be most interested in to start out with. Hopefully you all can read it. It's pretty small type, but you're young. Okay. And any extras, can you sort of pile up somewhere or look out for them when you leave and give them back to me, because I'm going to give some of those to those to my data structures class as well. All right. Let's talk a little bit about VI first. So I log in, I look around, and you see that directory that I created on Monday is still there, Spring 2013 167. So I'm going to change into that. And I'm going to go into homework 1, and I'm just going to open up hello.cpp with my editor, vim hello.cpp. Okay, and let's talk a little bit about Vim. Hopefully a lot of you have had a chance to look at the tutorial, and so some of this might be a little bit of repetition. VI, I guess the first thing to teach about VI is how to quit VI, because it's not at all clear how to quit VI. If you start VI and you're in command mode, okay, remember I said last time that there are these two sort of modes. There's the insert mode where you're actually manipulating text, and then there's on top of it there's this command mode, and it's the same keyboard. It's just you use the keyboard sometimes to insert characters and use the keyboard other times to actually do commands. When you first start up VI, you're in command mode. One of the things you can do in command mode is type the colon key. If you type the colon key, you see down here you get a little command prompt. And if you want to quit, just put a Q there and hit enter. Not at all obvious that that's how you quit VI, and there's a lot of funny stories about people starting up VI and having no idea how to get out of it other than just close the terminal. So now you know how to quit VI. Usually you want to save some changes, so I'm going to put a comment up here. Here's a modification of my file, and you see this little word down here that tells me I'm in insert mode. I can't save this file, I can't update the file unless I get into command mode. Do you remember how to get into command mode? Hit escape. Now to save this thing you hit colon and W and enter. And it says hello.cpp 10 lines, 169 characters written. That's Vim's way of saying that it's saved the file. And then if you want to quit, :Q. Okay, here's an additional modification. Now, a lot of times you just want to save it and quit at the same time. :WQ. And you've saved it and quit at the same time. And if I go in there and look at it, you see that that additional modification is there. Lots of different ways to do the same thing. Really cool VI people do the following. Really cool people just hit Shift-ZZ. So you hold down the Shift key, you hit Z twice, and it writes and quits. I don't know why. Go ahead.
Is there a way to copy things from a different compiler into the
From a different editor?
Yeah.
Yes, absolutely. And we'll talk about that more advanced usage a little bit later. But how were you trying to do that? Like, for what reason? Do you remember?
I had code written in a different, shell.
Okay.
And then I wanted to put it into Vim and it just gave me that.
So let me show you how to do it in Windows in PuTTY, and then I'll show you. Let's go back into this guy. I'll come back to that. Remind me to come back to that. So here I am again back in hello.cpp. When I first fire this thing up, I'm in command mode. How do I move around in the file? Does anybody remember how to move around in VI? How do you move your cursor around? HJKL, exactly. So the whole thing is designed to keep your fingers on the home keys if you've done keyboard typing. So J moves you down, K moves you up. And I'm able to move that cursor around. I'm not actually typing letters into the file. J in command mode or in escape mode is the command to move the cursor down one row. K is the command to move it up one row. If I'm in insert mode and I start hitting J and K, I'm just going to start getting J's and K's all over the place. Go ahead.
Can't you just use the arrow keys as well?
I can.
Okay.
So cool VI users don't use arrow keys, but it's okay, totally okay to use arrow keys. One advantage of arrow keys is, let's go down here and put myself in insert mode. So now J and K are just going to put letters in there. They're not going to move it around, right? The arrow keys, however, still work. And so that's one nice advantage of the arrow keys. It lets you move around and not have to jump out to command mode. So to move around up and down is K for up, J for down, L for right, that makes sense, right? And H for left. L is not a mnemonic for right. L is on the right side of this row of keys, and so it moves you to the right. And H is on the left side of this set of 4 keys, and so it moves you to the left. It's very much a physical thing rather than a mnemonic thing. Yeah?
So do people use all of these things just to basically go a lot faster?
Yes. Yeah. This is a programmer's editor. It's fast. Okay. So we know how to move up. K. We know how to move down. J. We know how to move right. L. We know how to move left. H. And I can do all that without leaving the home keys, or ish. The H sort of gets me out of place, but all right. If I move the cursor to a particular location and I want to start inserting some text, let me say I want to put something right in there. If I hit the I, it's going to put me into insert mode. So I puts me into insert mode. And I'm going to start typing before the cursor. And then if I hit escape, I've now inserted the word cruel into my sentence. Let's say that I wanted to put it, I don't know, I want to say put something, I can't think of a good modification. How about if I want to add some words after the exclamation point? I can hit A for after or append, and now I'm in insert mode, and I start putting characters after where the cursor was. And then I hit escape, and I've got that stuff in there. So I essentially puts text right before the cursor, and A sort of puts it right after. You'll get a sense for it as you use it. At the moment, that's all you need to write. That's all you need to write your programs. Let's start with an empty. So I'm going to go. Where do I want to go? Yeah, let's just start with an empty file. So I'm going to make a directory, call it Fahrenheit to Celsius. Open. It's not far. It's FAH, right? Oh well. Okay. So I'm going to make a new directory, and I'm going to make a new program. I'll call it Fahrenheit to Celsius. And all of your files, at least to start out with, should end in .cpp, which stands for C++. And here I start with an empty file. What I'd like to do is just walk through some of the basic anatomy of one of these programs. All right, so probably the minimal. Let me go into insert mode. So I hit I. Oops, I. I'm in insert mode. The minimal, the smallest running C++ program that you can do is this. In fact, we don't even need that. Oops. Oops. So I made some changes, I inserted some text, and then I hit :W and I wrote the file. Now, rather than constantly entering and leaving these files, what I encourage you to do is actually open up another terminal. They're surprisingly inexpensive, and they're going to save you a lot of effort. Did I open up the right one? I don't know. Let's see. Yes, I'm on math. So I'm going to go back into that same directory. So now I'm in the same place as this file that I'm editing. And if I hit Alt-Tab, I can switch quickly back and forth between the two windows. Why is this useful? Well, I can continue to edit over here, make changes, save them, and then I can go over to this window and compile it. And this is not a terribly interesting program. It won't do anything. But it is a fully functioning, it has all the elements of a C++ program that you need. What every C++ program needs is a main function. Every single C++ program that was ever written, a functioning C++ program that was ever written had a main function. This is where the execution of the instructions for the computer, this is where the computer goes to figure out what to do. And it's very often the case that the computer starts here at main and then will go off to lots of different places as directed by the main function. But it always starts here. So every C++ program has a main function. What I want to do for you guys is write a simple program that's going to ask the user for a temperature in degrees Fahrenheit, I think. let's see, I'm going to write a simple Fahrenheit to Celsius conversion program. Yes, so it's going to ask the user for degrees Fahrenheit and then give back to the user degrees Celsius. Really simple, nothing earth-shattering. The point of this exercise is really just to see what the pieces are of a functioning program. Okay, so some of this stuff I'll explain right now. Other things I'll be talking about in the coming days and weeks. So one of the things I'm going to do is include this IO stream header. This is necessary if you want to use the functions cin and cout. So if you want to print things out to the screen, you have to use the cout command, and the cout command is defined in that IOStream statement. If you want to get information from the user, you have to use the cin command, and the cin command is also defined in that same library, in that same header. So whenever you have a program that wants to print things out or read things in from the user, you have to have that statement at the top. All right. Slightly more subtly, if you're going to be using cin and cout, you have to have this statement as well. I will explain the namespace thing probably around week 10 or week 12. Once you have one window editing and the other window compiling, I encourage you to make tiny changes and then compile. And a very good rule of thumb is to always work from a program that compiles. So you make a change, you save it, you compile it. Make a change, save it, compile it. Just keep running in that circle. It's often the beginning student's habit to write 10 or 12 or 15 lines of code and then try to compile it, and then there are all sorts of syntax errors, and they're often lost. They have no idea where they should go to try to fix and resolve some of the errors. So a good rule of thumb is to always work from a functioning or a compiling program.
Can you purposely put in an error so it's good?
I will, but in a minute. Right now there's, yeah, in a minute. All right, so I need a variable. And again, some of this stuff I'm going to have to explain later. Let's just call it C. So we'll call this, this is the variable that's going to, the user supplied degrees Celsius. Now, this is just me creating a place to hold that number. What I'm going to do is ask for I'm going to ask the user, so I'm going to print this out to the screen and say enter degrees Celsius. And then assuming that the user types some value and hits enter, I'm going to get that value and put it in the variable C. So this first line is to prompt the user to enter a value, and the next line is retrieve. I don't know if I spelled retrieve right, but retrieve the value from the keyboard. So after this line occurs, sitting inside this variable C is whatever the user wants to convert. Now you have to know the formula for conversion from Celsius to Fahrenheit. In fact, let me get another variable. one thing computers are really good at is computation, and what I'm going to do is compute the degrees Fahrenheit. And I can't remember what I said I was doing. Am I converting from Fahrenheit to Celsius or vice versa? I think I want to go Fahrenheit to Celsius. Sorry.
How did you switch the line?
I guess I'll sprinkle in a few VI tips here. VI is not just about manipulating characters, typewriter characters. It has built into it many commands for manipulating what I would call a text object. One text object is a whole line. Another text object is a word. Another text object is a sentence. Another text object is everything between an open curly brace and a closed curly brace. So there are all these different text objects, and you have no prayer of learning all of this stuff in the first week of class. My suggestion to you would be to ask me questions like I was just asked, and I'll answer or I won't answer depending on time, and try to add some of these skills to your repertoire as you go through the semester. By the end of the semester, if you're really diligent about not just using what you know, but trying to extend what you know about the editor, you'll be a really good VI user. Back here.
Enter degrees Celsius or degrees Fahrenheit.
Yeah, thank you. Yep. Thank you. So, back to the question, how did I switch these two guys? There's a shorthand for deleting a line, DD, in command mode, DD. But it doesn't just delete the line, it actually puts it in a buffer. And then I can go anywhere I want and hit P, and it'll put that line in the line after the cursor. So that's another quirky thing about VI. You have to figure out where stuff is going to go. So if I hit lowercase p here, it's going to go after the cursor. If I hit uppercase P, it's going to go on the cursor. If I hit lowercase u, I undo stuff. In command mode, lowercase u undoes stuff.
So you just type DD after the one you want to delete?
A DD on the line. So DD, and that line's gone. And then P to put it somewhere else. And then U to undo that, and U to undo that. Suppose you don't want to cut it. Suppose you want to copy it. You can hit YY. And then P. YY stands for yank. And DD stands for delete. And if you're really sharp, you can delete, say, 2 lines, D2D, and then you can paste them down here. Or I can delete 5 lines, D5D. Okay. That's enough. That's enough. So that's how you play around with lines. Okay, so I retrieved the value of f. I'm now ready to convert it to c, which is 5.0 divided by 9.0 times f minus 32. I looked that up before I got here. For example, if f is 32, what's c? 0. If f is 212, what's c? 100, and hopefully that works out. Okay. So I ask for the value of f, I get the value of f, and I put it in this variable. I compute the value of c and store it in a variable, and now I'm ready to present that result to the user. And I believe we have a functioning program. Oh, and I just violated my own rule, although I haven't done that many. Okay, so I should be compiling this thing often. So here's an error. Line 12. So you see down here, right down here, that means I'm on line 12 and I'm in column 3. So if you look at the error message, you see there's an error in the function called main, and it's on line 12. And the error is somewhat mysterious. It says this thing cannot be used as a function. I don't know. I'll see if I can figure it out here. Ah, I forgot to put a star between these two guys. So it doesn't guess that you mean multiplication when you have two parentheses next to each other. You have to explicitly put a multiplication operator in between. Go ahead, Danielle.
Is there a particular reason for using 5-point columns?
There is. I'll talk about that in a minute also.
What's the character after the D?
After the D.
And
Oh, ENDL?
oh, is that an L?
Yeah, that's ENDL. I'll talk about all of this stuff in a minute. So I write a little, I try to compile. Now it looks like I'm back to something that works. Let me demonstrate this thing. So you do period /a.out to run the program. Enter degrees Fahrenheit. I'll try 32 and hit enter, and then once I hit enter, it reads the 32, does all the calculation, and spits out the result nonstop. There's nothing to get in its way now. And the equivalent degrees Celsius is 0. A really important aspect of programming is testing to make sure you believe this. So what's another good test value?
-1.
Or
-1, really? You want to use stuff that you know, right? So you know that 212 is 100. So let's try 212, and we get 100. Does anybody know one other interesting one?
-40.
Yes. -40 is -40. Those are the three that I happen to know. -1, I don't know. So yeah, whenever you write a program, there's the whole idea of writing it, planning it, compiling it, and then making sure that it does what you actually want it to do. All right, let's look at these various elements here. So we talked a little bit about IOStream and main. The stuff between the curly braces, and VI is actually VI. If I put the cursor on one brace, it will highlight the other brace that corresponds to it. So see, if I move the cursor off of there, nothing. If I put the cursor on there, it automatically tells me what the matching brace is. This is pretty useful when you're trying to figure out, you've got nested blocks, trying to figure out what belongs to what. So that's called the body of the main program. The stuff between the curly braces is called the body of the main program. Every line that ends with a semicolon is called a statement. And semicolons are used to tell the computer where one instruction ends and the next one begins. So here is a statement that tells the computer to define this variable f. And the only way it knows that this statement is over is by the presence of that semicolon. And it sees that semicolon and says, okay, that's done. Now I'm going to see what the next command is. And it does it until it hits a semicolon and says, okay, that command's done. Now I'm going to see what the next command is. So these semicolons are really important. And if I leave one out, what happens is the compiler thinks that "FCC" is the command that you're actually trying to send, and "FCC" doesn't make sense to the compiler. So I get rid of that guy, and I try to compile. I forgot to compile. There we go. It says something like line 7, error expected initializer before double. Doesn't make much sense to me. I usually just go on the numbers here. Sometimes the error messages make sense. Let's go with the number here. And I move the cursor until I get to line 7. And it's never perfect, but it always sort of gets you in the vicinity of the error. So now you're in the vicinity of the error, you're looking around, and you're saying, oh, yeah, there should be a semicolon there. So you move your colon there, you move your cursor there, you hit insert, you type semicolon, you hit escape, and you save it, W, and then you go over here and you try again, and everything is lovely. Questions about that? Okay, so these semicolons divide one statement from another. The stuff in the blue after the double forward slashes, these are comments. These are things that the computer, essentially the computer encounters a pair of these double slashes and says, I'm going to ignore everything from the double slashes to the end of that line. And it's a way of dropping comments into your code to explain what's going on. I would never comment a program that I was writing in my office for my own personal use as much as I've commented this one right here. I don't need to, I just wouldn't do it. Okay, so I'm just putting these comments in for instructional purposes. When programs get really long, or when they have lots of additional functions associated with them, that's when you start using comments. You write a really complicated function with lots of different arguments, and you put a comment above it, and you say, here's how to use this function, and this is what it does. Okay. What are you've seen a couple of the errors. Let's talk a little bit about case sensitivity. So let's pretend I'm not careful about case, and I use capital F there, and I use lowercase f here and here. If I try to compile this, can anybody guess what's going to happen? Or will it be fine?
We don't know the value. So I guess we get an error message by input value.
It'll be before that. It'll actually be when I compile it, not when I run it. But you're close. It's going to say, I don't know what little f is.
Yeah, because you double F is capital F.
Yeah. So let me try that. Little f was not declared in this scope. So you go back over here and you see, oh yeah, I meant to use little f here. Or I can change the other ones to all the big F's. Either way. The computer is not very forgiving to tiny mistakes. And the tiny ones are the ones that are really hard to find. I don't think it's terribly productive. If you follow the advice that I've been giving, where you write a little bit and then you compile, and you write a little bit and you compile, and you get in that habit of bouncing back and forth, what it's going to help you do is isolate. You know that it was just compiling before I made that change, and now it's not compiling anymore, and I only changed this one line. It's got to be there somewhere, right? That's the logic. It's tough to develop these good habits, but I can guarantee you in the long term this semester it's going to save you some time. If you write 20 lines of code, you're going to spend an hour trying to figure out what's wrong with it. Whereas if you write a single line of code, it's going to take you 10 seconds to figure out what's wrong with it when it doesn't work. And it can be extremely frustrating. If you don't have a good eye for detail, if you don't have good attention to detail, this is a class that will help you develop that skill. Okay, somebody in the back row was asking about 5/9, why 5.0, 9.0. This is a subtlety that I will talk about later and remind you, but C++, the arithmetic operators are very sophisticated. In particular, the division operator is sophisticated. It knows what kinds of things it's being asked to divide. When it sees 5 and 9, it says, oh, I'm dividing integers, so I'm going to use whole number division. And whole number division, 5 divided by 9 is 0. And that's what it'll use there, and the thing will just fail. In fact, I think if we do this right, I will get nothing but 0 out of this, no matter what I put in. So let's try 212. Yeah. Let's try minus 40. I get minus 0, but yeah. Whatever that means. So I just know from my experience with C++ that I have to give a signal to the division operator that I want real number division, not whole number division. And the signal that you have to give is you have to give it a decimal. One or both of these, the numerator or the denominator, one or both of them has to be explicitly a real number. And the way that you signal to the compiler that this is a real number is to put a decimal point in there. And it just takes one, so I've got 5.0 in there, and this thing should now function correctly. Ooh. Oh, minus 212. Duh. 212. There we go. Yeah, so that's why. Was it Danielle that asked that? Yeah. Okay. I promise to remind you of that later when we do the arithmetic operators, which will be in the next couple of days. Let's talk a little bit about the user experience here. Granted, this is a very simple program. It reads in a value and it spits out a value. But I would grade this about a C in terms of user interface experience. To get an A on this, I would say you should have a sentence at the beginning that actually says what this program does to the user, right? I'm the programmer. I already know what it does. Right, but what have I done here? I've written a program, I've compiled it, I've handed it off to some user that has no idea how this thing works and is trusting me. So I might print out, this program converts degrees Fahrenheit to degrees Celsius. Like that. Don't worry that that end line ended up on the next line. C++ will ignore those line breaks. So now I'm up in sort of B territory for user experience. So I've made a little change. I'm going to compile. I haven't broken it. That's good. I run this thing and it says, this program converts degrees Fahrenheit to degrees Celsius. Enter degrees Fahrenheit. Now it's pretty obvious what's going on. And now I'm asking for degrees Fahrenheit. I type in, say, 212, hit enter, equivalent degrees Celsius 100. That's close. In fact, I might even say B+ territory. There's one last thing that I would like you guys to get in the practice of doing when you're writing these little interactive programs, and that is to give feedback. The only place you see 212 or 212 is right here, and what you want to do as a programmer is reassure the user that you have received the information correctly. So what you should do as the programmer is you should print out 212 degrees Fahrenheit is equivalent to 100 degrees Celsius. You repeat back to the user the information that the user gave to you. By doing that, what you've done is you've reassured the user that you understood what they said to you. So let's do that. So I'll just keep it simple. You entered F degrees Fahrenheit. The equivalent degrees Celsius is C. We'll just keep it simple for now. Okay, so this is user feedback. And let's see if I haven't broken anything. Write a little, compile a little. Now I'm going to run it. This program converts degrees Fahrenheit to degrees Celsius. Enter degrees Fahrenheit, 212. You enter 212 degrees Fahrenheit. The equivalent degrees Celsius is 100. And that reassures the user that, yes, we're using the same information. Obviously, on a tiny program like this, this is way overkill. But on a really sophisticated program where a lot of data coming in, a lot of data going out, you want to reassure the user that you have understood what's being asked of it. Okay. Questions about this? Above and beyond here. What would be a good above and beyond?
Maybe like meters to feet.
Yeah, okay, so you could just write a completely different program that does meters to feet. That's fine. If you were to do that, what I would want you to do, and this is really just to help you understand where I'm coming from, I would want you to put that in a completely separate file and submit that to me separately. And then at the top of the assigned program say, my above and beyond was to write a program that converts meters to feet, and you can find it in this file. All right. What about an above and there are above and beyonds that you could do in this program that I would accept just without having a separate file.
Change the temperature and temperature.
Sure. So offer an additional piece of information that says, oh, and it's also equivalent to this in degrees Kelvin. That would be enough. You could just add that onto this program and submit it in one file to me for grading. Then that would cover the above and beyond. And because by doing that above and beyond, you haven't interfered with the assigned problem that I asked for. So if your above and beyond is somehow different or interferes with the things that I'm looking for from your program, just do it in a separate program. But if it really just adds to it, and all of the functionality that I asked for is still there, then go ahead and submit it as one program. Is that clear?
So in terms of using this program, a conditional would be nice that you could solve for one level of
Absolutely.
Can you accept that as a
Yes, I would accept that because it still does what I ask. You would prompt at the beginning. This is a Fahrenheit Celsius converter. Which direction do you want to go? Ask for some choice. The user makes a choice. Then you drop into this thing, and I do this, and that's the assigned work. And then I do the other thing, and that's above and beyond. Yeah. Rach.
When you say that you want us to write what our above and beyond is, you mean like as comments with the
Yes.
not as like a
Not like some separate document. Up here you would say, I did this program with so-and-so. If you're working in a pair, remember you're allowed to do that. And the above and beyond is yada yada yada. Yeah, okay. So
you'll run our program and look at it actually.
oh yeah.
So you
And I will look at every one of your programs whether they work or not, and I'll look real hard at them if they don't work. Okay. I sometimes I spend way too long looking at certain people's programs because like I'll run it and it doesn't do what it's supposed to do, and I start looking at it and I start plowing through, and like 45 minutes later I'm still working on the same one. If I get to that point, I might just say, I can't figure it out. I'm done. And maybe if we're really curious, you can come and we can work together in office hours. So I will give it a good try to figure out what's going on with your program, but even I have limits. Okay, try to write your code neatly. This is not super neat, but one of the things that you want to look for is statements that are within the same matching braces should have the same level of indent. This is a way of signaling to you, the programmer, where various things are related with respect to blocks. statements should usually just be on one line, although I'm pretty flexible with that. It's okay to break statements, long statements across multiple lines, things like that. We'll talk much more about this syntax in the coming days. Let's pretend that I'm done now and I've written my program Fahrenheit to Celsius. Now we want to submit this thing for grading, and I just want to remind everybody how that works. So we run this text-based browser called Links, and you run it from within the directory where your file lives. So I'm in this folder, I look around and I see, yeah, the program that I want to submit is in the same directory. I type links, http, caret, 167 upload.html, and program or file to upload. Remember, this is case sensitive, FAHR. Call it whatever you want. Put your user ID in there. Just keep hitting tab until the submit button is lit up. Hit enter, and thanks for uploading your program. And then remember, the instructions, or some simple instructions, are down here. The one that I care about is quit, and this little Q and then the right parenthesis UIT is kind of signaling that Q is the thing to do here if you want to quit.
I have a question.
Yeah.
You said it was case sensitive.
Yes.
But the file has a capital F and capital C. You submitted one with
That's lowercase.
Oh, okay.
Yeah.
I guess that's the folder.
Oh, the folder name is, yes. Yes, you're right. And the file name had the yes. Another question? Yeah.
Yeah, will it work without the HTTP : //
It might. We can try it. If you ever have a question about some computer issue, programming question or whatever, the easiest thing to do is just to try it. Yeah, apparently it does. You're not going to break anything. Well, within reason anyway. Okay, we'll talk more about this on Friday. Please do sign up for a presentation question. I'd like to get everybody signed up so that I can give you a schedule on Friday.
Is there a way, should I come to an office hour to try to get what I missed the first class, or
You can watch that YouTube video.
YouTube video? Okay.
Do you know what I'm talking about?
Nope.
Okay, so go here and here. Oh, and let me, speaking of YouTube videos, I want to stop this thing.